Okay, hello Year 11 Extension 1. Today I'm just going to go through the stuff that we would have gone in class. Unfortunately, some of you are away, and I'm very aware of that. Stay safe, stay well, get better before you come back to school. But I'm just going to go through some of the stuff that we've gone in class today on the 20th of March. This next section is called Remainder Theorem and Factor Theorem. Now, last lesson we went through long division of polynomials and did the practice of that. Today we're going to actually look at proving and applying the factor theorem and remainder theorem for polynomials, and then being able to solve simple polynomial equations. Remainder theorem and factor theorem is actually a really important fact, two important theorems in the study of polynomials. So let's go through it. The first one is remainder theorem. Now I have it in this box over here. Remainder theorem tells us that if we have a polynomial p of x, and we have a constant alpha, so alpha, this red A looking thing, is just a number. And so if we, the theorem tells us, if we divide p of x by x minus alpha, so I'm just going to highlight this in a different color. If we do x minus alpha and we divide it, and we can do long division for this, the remainder is just going to be when we substitute alpha into that polynomial, so p of x. Now, to prove this, let's just note that x minus alpha is a polynomial of what degree? Well, it's actually degree 1. It's polynomial of degree 1. So if we remember from when we did long division, the division theorem tells us, oh, I'm going to close this. Division theorem tells us that if we were to divide polynomial p of x by x minus alpha, so p of x minus alpha, we can actually write it as this. So we can write as p of x is equal to x minus alpha times a polynomial quotient q of x plus a remainder r of x. We did that last lesson. This was the division theorem. So this is division theorem. Remember. Now, we also had another fact that the degree of the quotient, so x minus alpha, was going to be greater than the degree of the remainder. Now, if the degree is 1, the polynomial r of x minus alpha, if the degree is 1, then that means, so this implies that r of x has degree 0 or is equal to 0. So because the degree of x minus alpha is 1, and it's greater than the degree of r of x, and I'm just going to rewrite that here, so degree r of x, because it's greater than, r of x must have a degree 0 or degree equal to 0. So that means we can just replace r of x with r. We can just replace it with the number r. So this number has degree 0. That's why I'm writing it as r. So we can just rewrite polynomial is equal to x minus alpha q of x plus r. Now we want to show that p of alpha will give me the remainder. So let's just substitute p of alpha in. So I'm going to sub. So p of alpha is going to give us alpha minus alpha in that first bracket, q of alpha plus r. Now r doesn't have anything to do with alpha. If we look here, this will just give me 0. So therefore, p of x is just going to give me that term at the end, this r, which is exactly what we wanted to show. P of alpha will give me that remainder. So, just to sum up, what the remainder theorem tells me is that if I substitute alpha into my polynomial, that result will be what would happen if I divided by x minus alpha, that number alpha. So, let's actually use this fact. So this first question, find the remainder when this polynomial 3x to the power 4 minus 4x cubed plus 4x minus 8 is divided by x minus 2. And we're going to do it two ways. We're going to do long division, and then we're going to do it using remainder theorem. And hopefully you'll see that this remainder theorem is really powerful and really easy and quick to use. Now I'm just going to write here, just for some notation sake, I'm just going to call my polynomial this thing over here. I'm going to name my polynomial that. So let's do part A. We want to do long division. I'm going to go through this quite quickly. If you need a bit more work on this, have a look at the previous videos or the previous section. I'm not going to spend too much time going through this process as much. So here I've got 3x to the power 4 minus 4x cubed. I'm going to leave a gap for that square term plus 4x minus 8. So when I'm dividing, I'm just dividing the leading term by the leading term in my divisor, leading term in my quotient by the leading term in my divisor. X goes into 3x4, 3x cubed times. So I've got 3x4, actually I'll rewrite that a little bit, 3x cubed minus 6x cubed. And so I get, when I subtract, I get 2x cubed here. There's no term to draw down. I'm just going to leave a gap there. The next one, it's going to be, x goes into 2x cubed, 2x squared times. So here I'm going to have 2x cubed minus 4x squared. So that's when I multiply 2x squared into my divisor. I'm going to subtract the 2, so those 2x cubes cancel. And then when I subtract a negative 4x squared, I just get 4x squared. I draw that in the next term, plus 4x. Here I've got plus 4x, because x goes into 4x squared 4x times, 4x squared, and multiply it in again, minus 8x. So here I'm going to get 12x minus 8. And so I've got plus 12 to finish off. And then, so I've got 12x. Let's just check, minus 24. So when we subtract, we get 16 here. So the remainder that we would have gotten is 16. Our remainder, if we did long division, which you can use it to check your result, is 16. Now, we're going to try doing this again. We're going to try and find the remainder using the remainder theorem. So here, part B, remainder theorem. Now what I'm going to do is p of x is equal to, if you scroll back up, it was equal to 3x to the power 4, 3x to the power 4 minus 4x cubed plus 4x minus 8. That's my polynomial. The remainder theorem tells me that if I substitute alpha in, that's the same, the result will be the remainder if I divide it by x minus alpha. So for this question, we're dividing by x minus 2. So the value of alpha is just going to be equal to 2. Just this number here. Just remember, it's x minus alpha. So here we've got x minus 2, so alpha is just going to equal 2. So I'm going to substitute in p of my alpha, which is 2. So if we substitute 2 in, what do we get? It's equal to 3 times 2 to the power 4 minus 4, 2 to the power 3 plus 4 times 2 minus 8. I'm just going to evaluate this. 2 to the power 4 is just 16, so 3 times 16 is 48, minus 4 times 2 to the cube. 2 to the cube is 8, so 4 times 8 is 32, plus 4 times 2, which is 8, minus 8. And when we fix this all up, we end up getting 16, which is the exact number that we would have been expecting because of that long division. So hopefully you can start to see this remainder theorem is actually really powerful in helping answer a few of these questions and helping us figure out what the remainder is when we do a division, long division, polynomial division. I've got another question here. Now I'm going to scroll this down a bit. So this next question, a polynomial p of x, which is given here. So we've got x to the power 4 minus 2x cubed plus ax plus b has a remainder 3 after division by x minus 1 and has a remainder negative 5 after division by x plus 1. And we want to find a and b. So here we've got two unknowns in our polynomial, a and b, and we want to find what it is. So we're going to use our remainder theorem to help us solve this. Okay, so I'm going to apply my remainder theorem on both of these. So here we've got, when it's divided by x minus 1, it has a remainder 3. So let's do that first part. So if I've divided by x minus 1, my alpha value is just going to be 1. So here I'm going to go p of 1 is going to be equal to, okay, that's going to be equal to 3. That's what we have over here. So let's do that. So p of 1 is equal to 3, so I'm going to substitute 1 into my equation, so into my polynomial. So I've got 1 to the power 4 minus 2 times 1 to the power 3 plus a, because it's just 1 times a, plus b is equal to 3. Okay, so I'm just going to simplify this. So I've got 1 minus 2 here. So that's a plus b is equal to 3. So a plus b is equal to 4. Okay, that's the first piece of information we have. Part 2. Then we also know that if we divide by x plus 1, we have a remainder negative 5. So here, my alpha value here is going to be minus 1. Because it's x plus 1, and we use the fact that it's x minus alpha, alpha needs to be minus 1. And that'll give me negative 5. So let me write that out. P of negative 1 is going to be equal to negative 5. Okay, let's use that. So we've got negative 1 to the power 4 minus 2 times negative 1 cubed minus a, because we're doing minus 1, plus b is going to give me negative 5. Okay, cool. Let's simplify this. 1 to the power 4 is just 1. Now, because we have negative 1 cubed, that's going to be another negative. So we're going to have negative 1 from here. So negative 1 times negative 2 is going to be plus 2. So on this side, I'm going to have 3 minus a plus b is equal to negative 5. Okay, let's simplify this. So we've got a plus b is equal to negative a plus b is equal to negative 8. So now we have two equations. Now, we haven't covered this in class, but you might have done it in year 10, and I'll go through a few more practice skills on this next lesson. But you need to solve this simultaneously. So we've got these two equations. I've got a and negative a plus b to negative 8. So I need to solve these simultaneously. So I've got my two equations, 1, 2. I need to solve them simultaneously. I'm going to go through this process. Now, if you notice, we've got a positive a and a negative a. So I'm going to add the two equations together so that the a's cancel out. So I'm going to add 1 plus 2. I'm going to rewrite that. So I'm going to add equation 1 and equation 2. So the a's will cancel out. So the 2b will add 2b is equal to 4 plus minus 8 gives me negative 4. Okay, now that I've done that, I divide by 2, so I've got b is equal to negative 2. Then I'm going to substitute this back into equation 1. So sub b is equal to negative 2 into 1. And so I've got a minus 2 is equal to 4. So therefore, a is equal to 6. So therefore, my polynomial, p of x, if I was to write the whole thing out, is equal to, I'm going to go back up, x to the power 4 minus 2x cubed plus 6x minus 2. So that's what we get when we deal with remainder theorem. With remainder theorem, what we know is if we substitute our value in, so here, let me just summarize at the end here, just so I can wrap up this video. So remainder theorem. So summary, if I do, so I divide by, oh gosh, what happened here? Is equal to the remainder of p of x divided by x minus alpha. This is a very informal shorthand of it, but that's a quick summary of what we did in this first part. Now, there's going to be a second part which covers the next factor, the next section, so factor theorem, and how it actually, this fact that we use here is actually really important for us.